Northwest Airlines Flight 705 was a regularly scheduled flight from Miami, Florida to Portland, Oregon, with intermediate stops in Chicago, Spokane, and Seattle. Severe thunderstorm activity existed in the greater Miami area at the time of the accident. A large squall line existed to the northwest, with cumulonimbus cloud tops to 30,000 feet. The captain of Flight 705 was briefed by the inbound crew, who described the approaching storm front. The inbound crew had been able to overfly the weather prior to descent into Miami earlier that morning. This resulted in a plan by the crew of Flight 705 to depart to the southeast, gain altitude clear of the weather, and then fly over the heaviest weather concentrations when joining the planned route to Chicago. Flight 705 departed Miami at 13:35 and conducted a series of turns to the south, southwest, and then northwest while climbing in light turbulence. At 13:42, as a climb toward 15,000 feet was begun, heavy turbulence was encountered for 3 minutes. After leveling at 15,000 feet, the flight was cleared to 25,000 feet and resumed the climb. The airplane climbed in a right turn with a brief 12-second level off at 17,500 feet. Resuming the climb, the flight again encountered heavy turbulence. Vertical speed increased to approximately 9,000 feet per minute, and airspeed decreased from 270 knots to 215 knots. It was believed by investigators that at this point the flight encountered a severe vertical column of air, resulting in the increased rate of climb, airspeed fluctuations, and an extreme nose-high attitude. Perceiving the rapidly increasing attitude and decreasing airspeed as an impending stall, investigators believed that the captain responded by applying full nose-down elevator and full nose-down stabilizer trim. The airplane's rapid response to the nose-down pitch commands resulted in high negative G forces which approached negative 3 Gs. It was also believed that the negative G forces prevented the pilot from making any corrective control inputs for nearly 7 seconds, and the controls remained in a position to command a nose-down pitch. As the pitchover continued, the dive angle became nearly vertical and airspeed rapidly increased to the 470 knot maximum recording limit of the flight data recorder. It was believed that the airplane continued to accelerate beyond 470 knots, though the recorder was not capable of indicating a higher airspeed. Investigators further concluded that in an attempt to arrest the dive, the pilot flying applied full nose-up elevator and full nose-up stabilizer trim. However, the airplane did not respond to these control inputs. Post-accident analysis led to the conclusion that during the high-speed dive, shock waves would have formed on both the upper and lower surfaces of the horizontal stabilizer in front of the elevator. These shock waves would degrade elevator effectiveness, inhibiting the ability to increase pitch. In addition, it was learned that the high nose-down stabilizer trim position, which had been commanded by the pilot at the beginning of the upset, would have transmitted high aerodynamic forces into the stabilizer structural attachment system. It was believed by investigators that the combination of these high aerodynamic forces and the additional torque generated by application of full nose-up elevator exceeded the trim motor's capability, resulting in a stalled drive condition. The stalled drive motor was unable to move the horizontal stabilizer in the commanded nose-up direction, preventing recovery from the dive. The investigators concluded that as a result of the high flight loads exceeding the designed structural capability of the airplane subsequently broke up in flight. The entire accident sequence, from the initial pitch upset to in-flight breakup, lasted approximately 45 seconds.